Hi, this is Erica Diamond. Today we will be joined by a very special guest, George Stevens, a renowned theoretical physicist. Just 40 years ago, a lot of the stuff we have was science fiction. Due to the urgency of the current situation of Earth, theoretical physicists have been working around the clock to try and find a way to stop the asteroid storm from approaching at an alarming rate.
Yes, we have come very far in our quest to understand theoretical physics due to the circumstances the Earth is in. The past 20 years, we have proved string theory, allowing us to understand how to bend space and time to help prevent the Earth's impending doom.
So basically, you're working to understand time travel?
Not exactly. The concept of time travel goes far beyond what we know how to do, and it can have some serious consequences. For example, the grandfather paradox can show you how time travel can go wrong. If a kid goes back in time and kills his grandfather, he can no longer be born. But then the kid won't be born again, so the kid won't be there to kill his grandfather, so it creates a loop. Now the solution is that two new realities exist, one without the grandpa and one with the grandpa. So what we are trying to do here is not go back in time to increase our understanding, but alter the space so that this asteroid passes by Earth. The first string revolution occurred in the early 1980s when Michael Green, Queen Mary, and John Schwartz from Caltech discovered superstrings. Superstrings had no tachyons, which are particles that could move faster than the speed of light, and had a consistent interaction on the subatomic level. Furthermore, they predicted a group for the fundamental forces. They had a natural low energy and were living in 10 space-time dimensions. Soon after, new strings were found, leading to a total of 5 string theories.
So you're telling me that there's a theoretical particle faster than the speed of light?
Yeah, but it's not theoretical anymore. Scientist Tanya Langley proved it in the year 2025, and it has been accepted around the world.
Wow, that's insane. How has this helped you understand the fabric of space?
Well, the tachyon allows us to travel faster than light, so galaxies were 389 light years away are now closer. But it didn't help us understand string theory. The string theory came from the 1980s, didn't involve tachyons. Because of this, the string theory was only proven in 2034 by Toby Whittle.
What exactly is the string theory?
String theory is a small part of the theory of everything. It says that the fundamental building blocks of nature are more like strings and not points. They extend and connect to each atom, and the length that we have seen is the smallest scale, even with the strongest microscope on Earth. The advantage of strings over points is that they can vibrate in an infinite number of ways, and as of the past of 2018, the string had only been estimated by long equations that would take more than 7 to 10 minutes to explain, even with a strong basis in calculus.
So because the string theory was proven, great minds like Einstein and Stephen Hawking's life, work, and ideas to understand the universe were almost spot on?
Yeah, the string theory helps us understand space and how the universe works.
So how does the string theory connect to space?
Well, since string theory is proven correct, we now know that space-time is 10-dimensional instead of just 4. And even some of these dimensions have been proven to be small, they still have an impact on the world.
The idea of smaller dimensions was created years before string theory by Theodore Kaluza and Oscar Klein. They thought a dimension could bend and rejoin itself, causing it to look like a circle. These circles would be so small they would not even be able to be seen by the strongest microscope on Earth. Those are dimensions hidden from view, but theoretical physicist Hayden Burks found remnants of the dimensions imprinted on a cosmic microwave background from the Big Bang Theory. That has helped us to get to where we are today in the realm of theoretical physics.
While not everyone can understand the complex mechanics and concepts in theoretical physics, everyone has someone to relate to. Penny from the Big Bang Theory. As Sheldon tries to help Penny, maybe he can help you too.
Looks like some serious stuff. Leonard, did you do this?
Actually, that's my work.
Wow.
Yeah, well, it's just some quantum mechanics with a little string theory doodling around the edges. That part there, that's just a joke. It's a spoof of the Born-Oppenheimer approximation.
So you're like one of those beautiful mind genius guys.
Yeah.
Wow, that was really interesting. Thank you for that, Doctor. I just have a few more questions for you. How does everything relate to what we see today?
Well, theoretical physics is helping us understand space travel better than ever before. We are able to travel faster than the speed of light using tachyons, even though we have a mass. And we are able to use the strings of string theory to bend space.
And all of this will help stop the asteroid from hitting Earth?
Yeah, other than bending space-time using string theory, we are able to use black holes. A black hole is an object with a high mass with a gravity that's so strong that not even light can escape it. It's created when a star runs out of fuel and it starts to collapse on itself, and it has a mass 3 times the mass of our sun. Recently, in 2030, the Hubble Space Telescope got sucked into a black hole, but communication never stopped. After numerous tests, we were able to determine something, that the black hole doesn't actually teleport you, but if we have a point of A and a point of B, it actually just brings them closer together. So B just gets moved right here instead of us having to travel the whole distance.
Wow. Well, thank you for your time, Doctor.
You're welcome.
This is Erica Diamond from 60 Light Years Away. Thank you for watching the video.
Bang Theory. As Sheldon tries to help Penny, maybe he can help you too. Wow. Wait, is that you?
We need to have a cut there.